Notes 5-6, Grafting Proportional Relationships. The objective is to identify proportional relationships, analyze proportional relationships, the Common Core State Standards list, and the mathematical practices. It says, if two quantities are proportional, the graph is a straight line that passes through the origin. Number 1, Miranda earns $15 per hour for babysitting. Number 1, we're going to write an equation to model this situation. We can use the equation y is equal to kx. So our constant is your $15. That's how much she makes per hour. The hour we don't know. That's your x. And the y is what she would have earned. Part B says complete the table and graph the data. So if she doesn't babysit, she's not going to make any money. If she babysits for 1 hour, that would be 15 times 1 to give you $15. If she babysits for 2 hours, that would be 15 times 2, which is $30. 3 hours is 15 times 3, which is 45. And 15 times 4 gives you 60. And we're going to graph. So at 0, 0, she's not making any money. She's not working. At 1, she makes $15. 2 hours, $30. 3 hours, $45. And 4, $60. If we were to connect the lines, we can see that it would be a straight line that passes through the origin. This is your origin right here at 0, 0. So since she's making $15 per hour, that's your constant of proportionality. So is the amount of money she earns proportional to the number of hours she spends babysitting? That would be yes. She's making $15 each hour. You can also tell that it's a straight line that passes through the origin. Also, the constant of proportionality is $15 per hour. So since her rate of pay is the same per hour, this is proportional. Number 2, determine whether the graphs show a proportional relationship. Explain your reasoning. So we have 2 graphs up here. We have table 1 and table 2. Our x value on both tables is the number of hours, and on our y value on both tables, it is the total cost. Our scales are exactly the same. But in our first graph, we can notice that it starts at 30. 0 hours, $30. In the second table, at 0, it passes through the origin. So that makes it proportional. So in the first graph, these are not a proportional relationship because the line does not pass through the origin. But in the second graph, since the line does pass through the origin, it is proportional. So this is yes, the line passes through the origin. You can also find the constant of proportionality. So in the first one, we have 30 over 0, and we can see that the second is 1 hour, and we have 75 over 1. We have 2 hours, 120 over 2. That equals 60 over 1. So we can see that when we find the constant of proportionality, it's not proportional. In the second table, we can see that when we have 1 hour, we have earned $45. 2 hours, 90 over 2, which gives you 45 over 1. So we can see already that they are proportional. Number 3, the number of gallons of paint required is proportional for the number of square feet of surface to be painted. The graph shows a relationship for the square feet, which is your x value, and your number of gallons, which is your y value. So we have our graph showing the proportional relationship, and the first thing we want to do is find the constant of proportionality. So that is your y over your x. So we can pick any points on it, and we can see over here, this is already simplified, your y is your 1 over 400. So that's your constant of proportionality. So we can look at the 800 square feet to 2 gallons. So it would be 2 over 800, which simplifies down to 1 over 400. Interpret the constant of proportionality. This means that 1 gallon covers 400 feet squared. Number 4. The cost C of hiring a taxi is given by the formula C equals 4 plus 2m, where the initial cost is $4 and the m is the number of miles driven. Part A says make a table showing the cost of hiring the taxi to drive 1, 2, 3, and 4 miles. So 1, 2, 3, 4. So we want to substitute in. So here's our equation. 4 plus, so 4 is the initial cost, plus 2 times your number of minutes gives your total cost. So doing the order of operations, we have to do the multiplication first. So we get 6. For 2 miles, it's 4 plus 2 times 2 to give you your cost. 2 times 2 is 4, so 4 plus 4 is 8. 3 miles is 4 plus 2 times 3. Order of operations, we have to multiply first. So we get 4 plus 6, which is 10. 4 miles, so we do 4 plus 2 times 4 to give you 8, plus 4, which is 12. So now we're going to do part B, which is graph the data. On our x-axis, we have our miles. On our y-axis, we have the cost. We can label the x 1, 2, 3, 4, and we can go by 2's for the cost. 2, 4, 6, 8, 10, 12. So we're going to graph what we did on our table. So we have 1 mile gives you $6. 2 miles gives you $8. 3 miles gives you $10. And 4 miles gives you $12. If we drew a straight line through this, we would see that it does not pass through the origin. So this is not proportional. C. Determine whether the cost of the taxi is proportional to the number of miles driven. Explain your reasoning. So to find your constant of proportionality, it's your y over your x. So when we take our total cost, which is your y, and your miles is x, we get 6 over 1. The second one is $8 for 2 hours, which gives you 4 over 1. So right now we can see that they're not proportional. Also, if you look at your graph, or the line does not pass through the origin. So those are the 2 ways you can figure out if your information is proportional or not. If your constant proportionality is the same, we can see we have 6 over 1 and 4 over 1. That means that it's different cost per hour, and also the line does not pass through the origin.